So we've just learnt about how atoms are with neutrons and protons in the nucleus, mostly empty space with electrons orbiting the nucleus. It wasn't always like that though. Over time models have changed, and this is a really good example of how using new scientific evidence leads to changes in the scientific viewpoints, the scientific beliefs. So thousands of years ago, atoms were thought to be really, really small, which is true, but solid and not being able to split up into any small particles. However, the discovery of the electron meant that the model had to be changed, because we now know electrons come from atoms, and so the atoms must be subdivided, so this model must have been wrong. So Thomson came up with the idea of the plum pudding model. Plum pudding model was a positively charged sphere with negative electrons scattered within it. But this wasn't the complete picture either. Over time, a man called Rutherford did an alpha scattering experiment. So Rutherford did the alpha scattering experiment, and we're going to go into more detail on this in a minute. And what this showed was that the nucleus was small and dense and charged, and the electrons orbited at a distance from the nucleus. So atoms, mostly empty space, electrons orbiting at a distance, and a charged, small, dense nucleus. After Rutherford's discovery, Bohr discovered that electrons could be at different distances from the nucleus. Then the proton was discovered, showing that the nucleus could be split up into protons, but still we hadn't discovered the neutron. That came right at the end, and that was by a man called Chadwick. So now let's go into more detail on this Rutherford alpha scattering experiment. So what should have happened if Thomson's plum pudding model was correct? So plum pudding, positive sphere, negative electrons scattered randomly in it. What Rutherford did is he fired alpha. He fired alpha scattering, alpha radiation at a gold foil. And if the gold foil was made up of plum pudding atoms, all that would have happened was all of the alpha would have gone through. Every single last bit of alpha would have gone through if this was true. If the plum pudding model was true, all of the alpha would have gone through. But what actually happened when Rutherford did the experiment is he found that some of the alpha, actually no, not some, pretty much all of the alpha, most of the alpha, like 99% of the alpha went straight through. And what this showed is that the atom was mostly empty space. But what showed that the plum pudding must be wrong was that some of the alpha was deflected. Some of the alpha was deflected. And I've shown that by that. And an absolutely tiny amount of the alpha radiation was deflected straight back where it came from. Through a large angle, straight back where it came from. And the reason why this must be, Rutherford came up with this nuclear model. So most went straight through because atoms empty space. Then the next result, some were deflected. So I'm going to do it down here. And the reason why they were deflected is because alpha radiation has got positively charged. So what Rutherford decided was that the nucleus must have been charged, so it repels. Some deflected due to repulsion. And the final result was this result here, number 3. Number 3 was deflected straight back, showing that the nucleus was small and dense. And because these three results most going straight through, some being deflected and some being deflected straight back. Because these results were not hypothesized, we could prove that the plum pudding model must have been wrong. So what Rutherford did is he came up with a nuclear model. Rutherford's nuclear model was simply that we've got a small, dense, positively charged nucleus with the electrons orbiting around it and mostly empty space. So mostly empty space, small dense nucleus, and that was charged with electrons orbiting. So that's how we went from Thomson's plum pudding model to Rutherford's nuclear model, because if the plum pudding model was correct, the alpha radiation would have all gone straight through, but that wasn't the case. Most did go straight through because atoms empty space, mostly empty space. Some were deflected due to the proportion of the positively charged alpha and the positively charged nucleus, and a very, very small number were deflected straight back, showing that the nucleus was small and dense